This video is about more practice for graphing piecewise functions. Now let's talk about how to graph piecewise functions. First of all, know the difference between the symbols. When you have a greater than or less than, means not included. So we got to use the open circle. When you have a greater than or equal to or less than equal to, means included. So we got to use a closed circle. How to memorize this? We use a happy face and a angry face to memorize. When you have a greater than or less than, no equal sign means open circle. If you want to sketch inequality function, you have to use a dotted line. We call this is a happy face. Dotted line means when you graph y greater than 2x plus 3, then you use a dotted line to sketch the linear function and shade the portion above the line. For piecewise function, this open circle, that's referred to the boundary. When you use number line to show the inequality, then you use the open circle for number line when you have greater than or less than. When you have greater than or equal to, less than equal to, you got to use a closed circle. For linear inequality function, you have to use a solid line. So we call this is an angry face. When we sketch the linear inequality function, y greater than equal to 2x plus 3, you have to use a solid line to sketch this linear function and then shade the portion above the line. But when you sketch piecewise function for greater than or equal to, less than equal to, you have to use a closed circle for boundary. And for number line, if you have greater than or equal to, less than equal to, you have to use a closed circle. Next, understand what the boundary mean. We have 4 types of boundaries. X greater than a means all value to the right of a, which means you have to use a and a plus 1 or a plus 2, keep going when you set up the table. X greater than a and less than b means all value between a and b. When x less than b means all values to the left of b, means when you set up table, you use b, b minus 1, b minus 2, keep going. When x equals c, only plot a single point. Then remember, create a table for each piece. Your table must include the boundaries if the boundary is in the domain. Normally, for a linear function, plot 2 points, because 2 points determine a straight line. For a curve, plot at least 3 points. Last step, determine if the boundaries are open or closed circle, and then you graph. For number 5, f of x equals 1 over x when x less than 0, and equals the cubic root of x when x greater than or equal to 0. For the first piece, that is a rational function. Since this is a parent rational function, we know the graph will be like this. And x less than 0, which means we need a number is less than 0, like -1, -2, and so on. In other words, this will be the graph we're looking for. That is x less than 0. For parent function, we need to remember for this part that x here is 1 over x. We got to use -1/2, -1 and -2. We got -2, -1 and -1/2. That's the table we set up. So we plot these 3 points. -1/2, that is 2. Let's go here. -1, -1. And -2 is -1 over 2. So we connect these 3 points. That's the graph for first piece. So it's very important for you to remember the parent function. Now let's go to the second piece. X greater than equal to 0. Since 0 is the domain of this cubic root of x, you got to use 0. Then we need number greater than 0, like 1, 2, 3. Now we can make a table. X and a cubic root of x. Start from 0, 1, then here's 8, 0, 1, and 2. Check the boundary point. It's a closed circle. So we will plot these 3 points. 0, 0 is here, closed circle. Then 1, 1. 8, 2. It's here. Now we got to connect these 3 points. Now we look for the domain. We couldn't find the very left point and we couldn't find the very right point. That's why domain is all real numbers. We do from -infinity to +infinity. For range, we couldn't find the very bottom point. That's why it's from -infinity. We couldn't find the very top point. It's still infinity. So for domain range, both are real numbers. Now let's go to number 6. F of x equals 3 plus x, x between -3 to 0. This is a linear function. We need 2 points. 2 points determine a straight line. Using the boundary points. So we will set up the table. X, here's a 3 plus x. -3, 0. Then we plug in 3 plus -3 equal to 0. 3 plus 0 equals to 3. Then check the open circle or closed circle. Equal sign means a closed circle here. This is an open circle. So we plot these 2 points on the graphing paper. We got -3, 0, close circle, and 0, 3. It's open circle, connect. This is the first piece. For second piece, that's a single point, 0, 4. It's over here. For third piece, this is a square root of function and x greater than 0. That means we need a 1, 2, 3. For square root of function, the graph look like this. We need 3 points. So we set up table. This is x. Here's the square root of x. You have to use boundary points because for this boundary point, it's in the domain. Then we got to use 1, 4. So we got 0, 1, 2. Let's plot these 3 points. 0, 0. This is an open circle because no equal sign. So open circle. 1, 1. It's here. 4, 2. It's here. Then connect these 3 points. Draw the curve. Show the arrow. Then let's check domain. We did find the very left point, that is -3. No ending points on the right side. So that's the domain. We find the very bottom point, that's 0. But since it's a closed circle, so that's 0. No ending point to the top. That will be the range. Now let's go to one more example. F of x equals -x squared minus 1 when x between -2 and 1. This is a quadratic function. The key point is the vertex. According to ax minus h squared plus k format, the vertex will be 0 and -1. So we can sketch this graph. 0, -1 is here, and this is open down because a is less than 0. So graph like this. Suppose this part is -2, it's closed circle. 1 is over here. It's an open circle. So basically, this is the graph for the first piece. We need a table. This is x, this is -x squared minus 1. Definitely you got to use the boundary point, -2 and 1. And also remember you have to use the vertex point, 0. So we plug in -2 squared minus 1 equals -5. -0 squared minus 1 equals -1. -1 squared minus 1, you got -2. Then for the first point, that's a closed circle. This is an open circle. Now we plot these 3 points. Get the -2, -5. Closed circle here. Then 0, -1. It's here. 1, -2. This is an open circle. Since the vertex is 0, -1, this will be the symmetric line. In other words, This is the point 2. This is the points. Then this time we can connect these 4 points we got. Now let's go to the second piece. This is a linear function. Basically, we just need 2 points. You are given 2 boundaries, so you have to use these 2 points. We got, here's x, 3x minus 2. Then 1, here's 2. Plug 1, 3 times 1 minus 2, that's equals to 1. 3 times 2 minus 2 equals 4. Then this is an open circle, this is a closed circle. Now we plot these 2 points. 1, 1 is still open circle here. Then 2, 4. This is a closed circle. Then connect these 2 points. Now we finish graphing. Then we look for the domain. Domain, we have very right point that is -2. We notice that 1 is not the domain. So we put the 1 over here, open parentheses. This is a bracket. Then union set with the still open parentheses 1, and then it's 2 is bracket. For range, we got a very bottom point that is -5. It's bracket. Then we got the top point that is -1, bracket. Union set with from here. This is 1 to 4. 4 is a bracket.